So we can start. Okay. So, respected principal sir, respected HOD of Department of Sciences, Maths and Humanities, Dr. Arun Pillai sir, respected Professor Prem Goel sir, our research guide to all of us, the respected HODs of all the departments, my dear colleagues and dear students, wishing you all a happy National Science Day. Now, as you know, this particular Science Day marks the discovery of the Raman effect by the Indian physicist Dr. C.V. Raman, and that's the reason why this particular day is celebrated. So, on this occasion, we have arranged a talk by Professor Dr. Arun Pillai, a scientist at Vikram Sarabhai Space Center, ISRO. Prior to that, I will now request our principal, Dr. Sandeep Joshi sir, who himself is a PhD from IIT Bombay in mechanical engineering with 2 patents on his name, to say a few enlightening words on this occasion. Over to you, Sandeep Joshi sir.
Yeah, namaste Sandeep sir, and namaste all the participants. I wish all of you very happy National Science Day. As Dr. Devulkar has mentioned that this day is celebrated as a token of gratitude towards the discovery of Raman effect on this day in 1928 by Dr. C.V. Raman, and subsequently on this invention of him, he won the Nobel Prize in 1930. This is the thematic Science Day every year, and every year some theme is declared for this particular celebration. So this year's theme is Future of Science and Technology in India, Impact on Education, Skills and Work. So keeping this theme in mind, we have arranged a talk by today's speaker, and this is very much relevant, and you all will definitely get latest information on the topic, that is Zero Gravity and Human Space Mission by Honorable Dr. Arun D.I. He himself is a ISRO scientist, and we all are eager to hear the knowledge sharing by Dr. Arun. I once again place my greetings on table to all of you on the occasion of National Science Day, and I guess we at Pillai College of Engineering will certainly serve the main motive behind celebration of this National Science Day, that promotion of science and technology activities in the young minds. Every year we are celebrating this, and this year also, fortunately, this is maybe the benefit which this corona pandemic has offered us, that online lecture, and that too specifically, though this year Science Day falls on Sunday, we are celebrating the day on the same day. So once again, I express my greetings on this very auspicious day, and everyone attending this program through Zoom meeting or on YouTube Live. Thank you, Devulkar sir, for organizing this talk. Thank you. Over to you, Devulkar.
Okay, thank you very much, sir, for your enlightening words. You told us even more information regarding the importance of the National Science Day. So once again, moving back to this is now the countdown to the actual talk, which will be given to us by Dr. Arun D.I. of Vikram Sarabhai Space Center. So the beginning of this lecture actually took place in June 2019, and during a conference, ICAM, that was arranged in Kannur. And it so happened that this information was passed to me by Professor Goel. And we took up this, we presented a paper at that particular point. And I saw anything that is connected with ISRO, it quickly it attracts me. So I saw a very silent person, a very down to earth person, right? Just taking, sitting in one particular corner, just coming into the limelight only when other students are asking him to take a photograph. And it is during that particular time that I interacted with Arun DI. And we also shared a couple of mails also regarding the kind of research on hydrogen storage that I was actually thinking at that time, and I'm still thinking about it right now. So the point which I want to stress out over here is this, that going to conferences is one actually increases your horizon of the thoughts which are there, horizons, your scientific horizon, right? So therefore, students, you should make it a habit to write down a research paper and just attending this particular conferences, which our college actually encourages a lot. So without further delay, first of all, I will like to tell something about the achievements of Dr. Arun DI. Arun DI is a scientist at the composite entity of Vikram Sarabhai Space Center, ISRO, and is responsible for the design, analysis, and realization of composite gas bottles for various missions of ISRO. As far as academics goes, he has actually, he's a bachelor degree in civil engineering from the College of Engineering, Trivandrum, and which is of course also known as Thiruvananthapuram. And he has a master's in construction technology and management from Indian Institute of Technology, Delhi, and a doctoral degree in aerospace smart materials from Indian Institute of Space Science and Technology, Baliamala. And his areas of interests include application of smart materials, polymer nanocomposites, biomedical applications, then space-based structures, and composite pressure systems for launch vehicles and spacecrafts, space policies, and legal understanding on space exploration. Not only that, but he has also published a book entitled Shape Memory Materials with CRC Press, Taylor and Francis Group. Okay, and in addition to that, he has generated many research articles about shape memory materials, smart and intelligent materials, spacecraft recovery technologies, which we only hear in the news, right? But he is the one who is actually getting his hands dirty on the floor and shaping up big missions like the GAGANYAAN, about which, of course, he is going to speak today. The point which I would like to bring to your notice over here, before I give it to Dr. Arun DI, is students, he started up with a bachelor degree in civil engineering, and he was so focused, he developed his skills and saw to it that ultimately he got the thing for which his heart ached for, right? And as our principal sir always, he harps upon this story that skill building is one of the key essentials of success. So I feel he's an example which all of us can take, that how he has actually built the skill in the right direction and he has reached his destination. So without further delay, I now invite Dr. Arun DI to begin his talk on zero gravity. Over to you now, Arun sir.
Thank you, Sandeep sir, for the nice words. I share the presentation without any delay. Now, is the screen visible now?
Yes, sir. Yes.
Yeah. Okay. So shall we begin?
Please go ahead, sir. You can begin, sir.
Yeah. So once again, thank you for the nice words, Dr. Sandeep. And I welcome you all to a wonderful Sunday. Good morning to one and all. Actually, Dr. Sandeep asked me to talk about GAGANYAAN straight away, but I believe talking directly about GAGANYAAN will be like watching a movie from the interval. So let us begin from the starting of space adventure. And we all are very fortunate enough to be born in around 50 years from the first space travel. So I believe what we are going to discuss in next 1 hour or so, you all must be aware of, but I've tried to put it in an order so that each of you will be able to be a lecturer someday and talk on the facts in an orderly manner. So that's the purpose of such lectures, right? So it's not a history lecture, of course, but don't worry, we'll have a time travel. So I work with the Vikram Sarabhai Space Center. As Dr. Sandeep has explained, and here I've titled the lecture as Zero Gravity because we are going to be in zero gravity for another 1 hour. And the image in the background of this slide, maybe you might have seen this picture. It is a view from the International Space Station, and the blue marble which you are seeing in the background is our Earth lighted up. And let us move on. So gravity is amply explained by our eminent scientists. Einstein and Newton have given the mathematical formulations. It is defined as the attractive between any objects in the universe with a finite mass and is separated by a distance. This is a 12th standard physics. We learned the equation. Gravity is proportional to the multiplication of the mass and the distance from the center of each of these masses. So what you're seeing is the field created by Earth. It's a simulation of the field created by Earth, by Sun, and Earth kind of a planet is revolving due to the effect of the gravity. Similarly, the gravity of Earth is also depending on the mass of Earth and the mass of the body which is being attracted, and the distance from the center of Earth to the body. So technically, we can say they are also separated by a distance and having finite mass, so they are also in gravity, for fun's sake. Okay, so this gentleman is familiar to you. He is Stephen Hawking. He is one of the fantastic person in the world of physics. You can see him floating in a zero gravity flight. Because it is not actually zero gravity. Gravity is reducing as we increase the distance from the center. As you see, r square it is. So when the distance increases, the gravity reduces. So finally, he is traveling in a parabolic path by a company called GoZeroG in a flight. And due to the parabolic path, which is somewhat similar to what we experience in a lift, in an elevator, the same effect is generated by flying the aeroplane in a parabolic path, which causes the effect of zero gravity. So this guy wanted to experience it, so they have taken him in a flight. So that is what generally we define as zero gravity, the effect of weightlessness. We'll move on a little further. Again, this gentleman is a familiar person. Wing Commander Rakesh Sharma. He was the only Indian, pure Indian by birth and by citizenship, who has traveled to space in 1984 on board Soyuz T-11 of Russia, the USSR that time. And he has spent almost 8 days aboard Salute space station, orbital space station. We'll see a small video of Rakesh Sharma talking with the then Prime Minister Indira Gandhi.
मगर अभी हमें आके पता लग रहा है कि ये जो ट्रेनिंग हमें मिली, ये ट्रेनिंग जरूरी थी, क्योंकि यदि हमारी डॉकिंग मनूवर हुआ है बगैर किसी तकलीफ के, हमें तो ऐसे लगा जैसे कि हम सिमुलेटर में ही बैठे हुए हैं। तो ये हमें सब बताता है कि जो ट्रेनिंग हुई है, कड़ी ट्रेनिंग की जरूरत थी, जिसकी वजह से हम बगैर किसी तकलीफ के सक्सेसफुल डॉकिंग कर पाए हैं।
The video is visible, right?
No, sir.
No? Okay.
No, sir. Video is not visible. Video is not visible, sir.
Now is it visible?
Yes, sir.
Yes.
ऊपर से भारत कैसा दिखता है आपको?
मैं बगैर किसी झिझक के कह सकता हूँ सारे जहां से अच्छा.
Yeah, that's what it is. You could see him talking with Srimati Indira Gandhi, and when she asked how India looks from space, so his answer was "Sare jahan se acha," and that's a wonderful response. And actually, he has gone to the presentation is visible right now. Have we come back to the presentation? Hello.
Yes, sir. Yes, sir.
Okay. So we'll continue. So actually, Rakesh Sharma has gone to space in the Cosmos program, where India and Russia had a collaboration, and another gentleman was also involved in the training exercises done as a backup crew. Another wing commander, Ravish Malhotra, but unfortunately he couldn't fly because Rakesh Sharma was chosen, and Rakesh Sharma is the mentor for ISRO in the upcoming GAGANYAAN mission. He currently lives in Ooty, a nice hill station in Tamil Nadu. Talking about the Indians in space, and these are the people who are born Indians and having citizenship of US and are chosen by NASA as astronauts. The first gentleman is Ravi John Verpatur Chari. He is one among the 18 people who are chosen for the moon and beyond. Yeah, he is Ravi Chari, Raja John Ravi Chari, who is been chosen as one among the 18 astronauts for the Artemis and Mars mission of future, and he is actually a US Air Force graduate from MIT. The second lady is Sunita Williams. She is a known figure. She has got a video of International Space Station where she floats around and explains about International Space Station. She is again a Navy officer, US Navy officer, and she has had some records of having most number of spacewalk by a lady and maximum time in space, which is now rewritten by some other lady. And the third person is again a very good memory, Kalpana Chawla, who couldn't come back because of the disaster of Columbia Space Shuttle in 2003. She was born in Haryana and done her graduation and joined NASA during her early 20s. She has also been an inspiration to many people who look up to space. Now, again, an Indian, this is a known figure and has been on discussion since few weeks, lady with Bindi in NASA. She has been a part of the Perseverance mission by NASA, and she was the guidance and control in charge for the Mars 2020 mission. Again, an inspiration. So this is the one small step, the first image which we get to see about space when we start studying in physics about gravity. The first image is Neil Armstrong standing in front of the US national flag, which is hoisted in moon in the Tranquility base. And you can see the three gentlemen who have traveled with Neil Armstrong, Michael Collins and Edwin Aldrin. We'll see another small video which talks about landing.
Okay, let's stop. Listen, tranquility base here. The Eagle has landed. Rocket tranquility, we copy you on the ground. You got a bunch of guys about to turn blue. With better, the 11 footprints are only compressed in the surface about 1 or 2 inches. I'm going to step off the limb now. It's one small step to man, one giant leap to mankind.
Yes, that is one small step for a man and one giant leap for mankind. The Eagle is the name of the spacecraft which has landed on Moon in the Tranquility Base, and this is an image of the Moon which we see. This was a photo taken by me in my terrace. So you also will be seeing the same image of Moon. You can see Apollo 11 marked on the photograph. Apollo 11. Could you see it? Apollo 11. All the other Apollo missions are also marked there, and you can see LUNAR missions by Russia, Chang'e mission by China, and our Chandrayaan, which unfortunately was not. We were not able to soft land it, but we are still on Moon. So next time when you see Moon, you can locate the Tranquility Base where Apollo 11 has landed. So we are fortunate enough to see people landing on Moon. It's straight in front of us. So enough of inspiration. Let us go to a little bit of science. This image in the left side shows the Milky Way galaxy, which is a spiral galaxy which we have studied in our school days. Its diameter is mentioned here. It's 1,25,000 light years. 1 light year is a distance traveled by light in 1 year. Speed of light, as we know, is 3 lakh kilometers, and that 3 lakh kilometer per second light travels for 1 year is what measured as a distance light year. And across the spiral galaxy, we have 125,000 light years as the diameter. And this is a location where we are. You can see the arrow pointing where our solar system exists. Sun with its 8 planets. Talking about solar system, we have got Sun occupying around 99.85% of the entire solar system space, and the other planets. 8 planets occupies 1.135%, and other bodies like debris, meteorites, comets, etc. occupies around 0.015%. We've got debris in space which are either man-made or natural debris. Meteorites which fly around. We've got zero gravity, as we have mentioned. As we go away from the center of the Earth, the gravity reduces. Then the magnetic field of planets, comets, radiation, high radiation from our sun, other stars, and the other parts of the galaxy, cosmic radiations. Then the temperature variations. Temperature vary from -150 to 200, 250 degrees Celsius in space. Then plasma, which is ions, charged ions, which can affect our human body cells or living cells. So we require special suit for surviving in space, which we'll discuss in the subsequent slides. Then we'll experience high vacuum, that is lack of pressure or air in space. And another information is the nearest star beyond our sun is around 4.35 light years, which is named as Proxima Centauri. And space, okay, we have talked enough of space. So what is space? We have seen all these movies. I think all of you might have gone through at least one of these movies. Gravity is there, Martian, Interstellar, Apollo 13. So all these movies define space amply. It talks like space is a vast area which is beyond the atmosphere of Earth. So if you have not seen, I would recommend students to go through, or faculties who are interested can go through and recommend for the students. These are wonderful movies. And we've got a Bollywood also there in that fun. Okay, so how to reach space. We have talked about space and surviving and going to space. So how to go to space? We need a vehicle. So a vehicle which carries us to space is known as a rocket or launch vehicle. Vehicle that launches to space is known as a rocket or launch vehicle. And you can see this is a familiar figure, the left extreme top. We have got something similar to our Diwali rockets. We have got somebody having rockets fitted in his chair. It's always weird sometimes. So this is a Chinese image. We've got a Chinese soldier making the rocket ready, and the bottom figure is Tipu Sultan, our Mysore king. who used rocketry against the British in his war. He and his father Hyder Ali has used, and that is considered as the pioneer effort in rocketry in India. And you can see the Mysorean sword rocket to the right extreme, which is now preserved in NASA, as well as ISRO is having a specimen of that. Basically, we know that the fundamental of rocketry is Newton's third law. Every action has got something opposite to it as a reaction. Coming on to modern rocketry, we've got few gentlemen who have contributed for rocketry. The first image is of Konstantin Tsiolkovsky, who was a school teacher, and he is fondly known as the father of modern astronautics. He was the one who proposed the idea of space exploration by means of rocketry. Second gentleman is Robert Goddard, who was honored by NASA by giving the Space Center's name as Goddard Space Center. He has written a book about reaching heights, extreme heights by means of rocketry in 1900s, beginning of 1900s. The third gentleman is a German, Hermann Oberth. He was the pioneer in German rocketry, which is the highlight of World War II. The V2 rockets, which later became the pioneers in space technology also. The fourth gentleman is Wernher von Braun. He is again a known figure. He was born German and is taken to US after the war. He was the director of Marshall Space Flight Center once, and he was a chief architect of Saturn V rocket, which is the one which took Neil Armstrong and people to moon. And moving on, again an inspiration. This is a movie, October Sky, which is based on true events. It's about a teenager getting inspired by Sputnik 1, which is the first satellite, first spacecraft, man-made spacecraft, which is sent by Russia in 1957. And this guy, looking at sky, sees the Sputnik flying by, and he gets inspired and makes his own rocket to go to space. Finally, he ends up becoming a NASA engineer. And Wernher von Braun, whom we have discussed about in the previous slide, is also portrayed in the movie. It's a must-watch for every science enthusiast, not only space science enthusiast, because it talks about inspiration. Talking about inspiration, this man and his rockets has been a tremendous energy to people around the globe, and he's been inspiring generations. Rocket science is made simple, and actually rocket science is used as a synonym for the toughest thing, but he has shown that this is a simple thing, accessible to everyone. And you can see the background image of his latest product, which is the Starship. And every other day you have a news of he testing this rocket, and he talks about the otherwise impossible things which he achieves. So it's an inspiration again. He talks about settling in Mars now. So he once said that he's working 80 hours a week. That is roughly 16 hours per day for 5 days. So that is actually something great. We generally look for 40 hours a week in offices. Okay, now moving on to rockets. These are the top images shows the different launch vehicles, or anything that launches something to space is called a launch vehicle or rocket. You can see the rockets from Saturn V, SLS, Space Shuttle, SpaceX, Russia, European Space Agency, and finally to the last right extreme, we can see PSLV as well as GSLV rockets. And satellites or spacecrafts are something that goes in a rocket to space, or launch vehicle as a passenger in launch vehicle to space. You can see International Space Station to the left extreme, and other spacecrafts and crew modules which takes men and material to space. So these is generally called spacecraft or satellites. And these are the various space agencies that are involved in space administration and space exploration. We've got ISRO, NASA, Russia, having Roscosmos, European Space Agency, and many other space agencies. But there exists a question, a big question: why do we do this? Why do we do the space exploration? Basically, we are a curious space a curious race. So we look up at sky and ask questions. You all might have asked questions. I have asked questions about the stars and sky. So the basic question to be answered, the fundamental questions need to be answered. For that, we explore space. We need to know where we came from, where we are going, the history of solar system and the future of solar system, expansion of technology. Remember that world wars have given us rockets, rocketry, space science. Wireless technology was a gift of world war. Even though war is bad, we have got many technologies evolved out of it, and create new industries. People like you, students, are looking up for technology-based jobs and administration-based jobs. There are ample opportunities in space sector. Help to foster peaceful connection between nations, knowledge exchange, survival. Yeah, that reminds of global positioning system, GPS, which we all have in our phone, which we are the regular users. Actually, it is a product of NASA, which we are using it. So that is actually knowledge exchange by space exploration. Then mass communication, agriculture, all these are known to you. So that is the explanation of why space exploration is required. And here is it all began. We have Sputnik 1, which is the first spacecraft, which is a sphere of around 60 centimeter diameter, and it spent around 90 days in orbit, having 2 radio transmitters, and it was giving out some beep sound while it was orbiting the Earth. And this was the inspiration for all the people. Even the movie October Sky was inspired by Sputnik 1 flight. It was in 1957. This was done by Russia, the then USSR. We are talking about human space flight. So the question again is why we need humans in space, because it is very risky. We talked about vacuum, zero gravity, effects of radiation, temperature, everything is coming to human body. When we go to space, we need to survive all those things. So why we need to spend humans? It's not only the scientific benefits that drives us, but the experience, real-time experience, and the survival which we need to learn for further exploration of space. So we need a right-hand experience. Another one, yes, it is challenging, so that develops technologies which will make us survive even on Earth conditions. And of course, President John F. Kennedy of US once said in his speech that the best of our abilities will be extracted once we go into further technologies and further challenges. So going to space increases the technological advances of all the sectors. But still, there is a question: why can't AI-based robot replace humans, or robonauts, humanoids? Why can't it be a replacement for humans in space exploration? Of course, it is a debatable, and it will be debated forever. Moving on, the first space exploration, the first human space exploration started in 1961 with Yuri Alexeyevich Gagarin, the first space traveler. He went in Vostok 1. You can see the bottom middle image shows the Vostok 1 capsule in which Yuri Gagarin has traveled, and you can see the our Birla Planetarium in Kolkata has got a sculpture of Neil Armstrong in memory of the space travel. And these are the names given by various nations for the space travelers. Astronauts is being called, is the name used by America, cosmonauts by Russia, taikonauts by China, and it is speculated that we will use our people as Vyomanauts. And as we all know, it all began as a competition between US and Russia. Russia started with the Soyuz, this was first Sputnik 1. Later, it explored into various areas. America didn't sit back. They went hand in hand with many of the technologies to compete with Russia. Actually, these people have developed intercontinental ballistic missiles for the World War, which were nuclear capable even, and which later turned into space exploration vehicle, as we tell that space exploration is for peaceful use. And this is how Sputnik initiated the space exploration 1957, which is called the geophysical year. And Sputnik 1 was launched in 1957, and Americans didn't sit back. They started Project Mercury in 1958, which is again a capsule to carry humans to space. Russia again secretly pursued the Vostok mission from Sputnik 1961. They could launch Vostok 3Ka rocket, in which Yuri Gagarin has traveled to space in Vostok 1 capsule. That was a slap onto Americans. They planned within a month. They planned another space travel with their first astronaut. Alan Shepard has gone in Freedom 7 spacecraft in 1961, followed by John Glenn 1962. Then Russia thought, okay, we'll go with a lady, Valentina Tereshkova, in Vostok 6. Vostok was a continuing mission. Vostok 1 to 6 people have gone, and Valentina Tereshkova has gone in 1963, followed by Svetlana, another lady, to space. US took a long time to take ladies to space for a spacewalk. The first all-female spacewalk happened in 2018 by Christina Koch and Jessica Meir, and we'll have a lady on moon soon by 2024. The moon mission which NASA is planning. People are being selected for that. And this was the beginning of another milestone in the space exploration. This is a famous moonshot speech by John F. Kennedy in 1961. So he raised the stakes of space race by setting goals of landing a man on moon and bringing him back safely by the end of 1960s. Unfortunately, he didn't live enough to see the man coming back, but still he inspired generations. So this is where it all began. Once they heard Kennedy, they started with NASA, started with Gemini mission in 1962, and around 10 missions happened in Gemini, under Gemini project by Titan 2 rockets. And the Russians didn't sit back. They competed with US with the Voshchod capsule, which could carry humans. Initially, it started with a single man flight, and later they expanded it to 3 man, but they couldn't stand in front of Gemini, which was far more advanced than Voshchod. So Russians went into another area. They started a spacewalk. The first spacewalk by a Russian or by a human is by Alexei Leonov, and on Voshchod 2 in 1965. So since Americans were beaten in spacewalk, they thought, okay, we'll move ahead with the development of world's heaviest rocket, which is Saturn V, which subsequently carried humans to space. And this is the beginning of Apollo, which was the human exploration mission of moon. Apollo started with Apollo 4. Apollo launches started with Apollo 4 actually, and Apollo 4 was a vehicle proving technology mission. Apollo 6 was a crew module testing. Apollo 5 lunar module testing. Apollo 7 again the crew module and lunar module docking and testing. Apollo 8 people went to space. They had the privilege of going to lunar orbit and moving around moon for another 3 days. Apollo 9 was again a lunar module maneuvering mission, because they had to pull out the lunar module from the Saturn V rocket and dock it with the orbital module. Then again, Apollo 10 was a dress rehearsal for the landing. Apollo 11, we have seen the one small step for man, the giant leap for the entire mankind. So we have landed on moon in Apollo 11 mission. Subsequently, 2, 3, 4, and 5 happened. Apollo 12, people have landed. Apollo 13, unfortunately, the crew module, the service module met with an accident. The oxygen tank in the service module bursted during a regular routine steering, which made the astronauts to go around the moon and come back. They couldn't land. Apollo, there is a movie, Apollo 13, which talks about the actual facts. of what happened in the mission. Apollo 14, people have landed. 15, again another mission where the first rover on the surface of moon is tested. You can see the rover to the right of the image, Apollo 15. Apollo 16, again another experimental mission. Apollo 17 was the last mission which happened in late 1970s. And then US have stopped the Apollo mission due to the funding constraint. And in 12 years of hard work, we had 6 moon landings, 12 men walked on moon, and around 350 kg of moon rock was brought to Earth and was distributed among various moon observers and space enthusiasts. So when US were exploring space, moon, Russia didn't plan to go to moon by human landing, or didn't plan a human landing. They looked up at orbiting station laboratories, and it started with Salute 1, which orbited Earth and served as a space laboratory. Then came Salute 2, 3, and 5, which were speculated as military observation later. Then Salute 6 came, which is again a laboratory. Salute 7, which is the space station into which our Rakesh Sharma has gone. Then US didn't sit back. They saw Russians doing with the orbital platforms. So they started with Skylab. Russia again came up with Mir. China has had Tiangong 1 and Tiangong 2 was being experimented in 2016. And the last image is International Space Station, which is serving as the science laboratory around Earth. For the past 20 years, we've had continuous human presence in International Space Station. It is actually a laboratory with habitable space around docked onto it. We've got docking pods for carrying men and materials. We've got solar panels which harnesses the power, and space station travels around 400 kilometers from the surface of the Earth as the orbital height, and it takes around 90 minutes to go around Earth and come back. 16 orbits, 16 sunrise and sunset people can see once they are aboard International Space Station. And it has got collaboration from NASA, Russia, Japan, European Space Agency, Canada, etc. And its life is being told as 2025. Okay, enough of competition. Initially, people have competed on space. Russia and America, they came together and joined hands in 1975 with the Apollo Soyuz mission, where you can see the image right extreme. Apollo capsule and the Soyuz capsule are docking in space, and these are the crew members who were on board that time, and they have done joint experiments and took photos of solar eclipse which was created on orbit. And post the competitions, they kept aside all the competitions as they moved on, and reusable space plane era began, where America has started with space shuttles, and you can see the various space shuttles which served US space exploration, NASA. And the first one is Enterprise, Columbia, Challenger, Discovery, Atlantis, and Endeavour. You can see the orange color tank is an external fuel tank. You can see the boosters, which are the largest solid propellant boosters on either side, the white color pointed boosters. Then the space shuttle, which carry men and material to space. Unfortunately, Columbia and Challenger met with tragic accidents, killing few people who went to space, but still they continued, and Endeavour was grounded in 2000, beginning of 2000s. Russia didn't sit back. They started with a similar configuration of space shuttle called Buran, Energia rocket-powered Buran, which actually didn't fly because it got destroyed in 2000s during a maintenance time. And it was actually more capable than the space shuttle which NASA has developed, but it didn't fly. China has come up with their own space flight. European Space Agency is developing their own space flight. And of course, India is having reusable launch vehicle. RLV stands for reusable launch vehicle. And it is a technology demonstration of the hypersonic re-entry coming back from space, called re-entry of the space shuttle or space capsule. Then the thermal protection system, which once we come back from space, due to the friction in the atmosphere, enormous amount of heat is generated that need to be survived to bring back the people and materials safely. So thermal protection is required. Then flight management also will be tested in the upcoming RLV. China didn't again sit back. They competed with the other people. They came up with the first human in space in Shenzhou 5, and he is Yang Liwi, who was a pilot. And China did this in China started actually the space exploration in 1970s, but they came up with the human space exploration in 2000s only. And now the age of commercial space transport has begun. Private companies are venturing in. SpaceX, Blue Origin, Sierra Nevada, many companies are there. And NASA even is promoting it by sending their astronauts. You might have seen the launch, which was a long-awaited thing. NASA is coming up with Orion and SLS, Space Launch Systems. Of course, accidents are inevitable. We have had tragedies related to space. We have had Apollo 1 crew who died in a fire accident on ground exercise. In 1967, the same year, Soyuz had a disaster while coming back from space, killing Komarov, who was a cosmonaut. The parachute didn't open, so he had a crash landing, and the Soyuz 11 crew got killed by the accident of depressurization of the crew module while coming back. Challenger space shuttle exploded around 70 seconds from launch, killing all the 7 crew members on board. Columbia space shuttle, as I've mentioned, killing Kalpana Chawla and other 6 people in 2003 while they were re-entering after a 16-day mission, STS-105 by NASA. Of course, that didn't stop us. We are moving further away to explore the deep space by means of scientific platforms. This is actually a lunar gateway platform which is being conceived by NASA and other space agencies. Russia is there. European Space Agency, Japanese Space Agency have joined together to form the Lunar Gateway, which will be a space platform that will be orbiting Moon and will be helpful for missions beyond Moon and Mars into the deeper areas of space. So we have talked about space and the beginning of human space flight explorations. Coming to Indian scenario, where Indian Space Research Organization is the agency that takes up the exploration of space for the peaceful use of humans. And what you are seeing is GSLV Mark III, which is the heaviest launch vehicle we have in the second launch pad of Satish Dhawan Space Center in Sriharikota, Andhra Pradesh. A brief history of ISRO, Indian Space Research Organization, started in 1960s, in the beginning of 1960s, and it was under the pioneer leadership, under the wonderful leadership of this gentleman, Vikram Sarabhai. He started he kindled the space exploration by establishing a rocket launching station in near to equator in a place called Tumba, which is a seashore village in Kerala, which later became VSSC. They launched the first rocket, sounding rocket, which is actually a small rocket which is used for space weather forecasting and study of the upper atmosphere. And thus it became TERS, Tumba Equatorial Rocket Launching Station. And it was established as INCOSPAR, International Corporation of Space and Research, which was under Department of Atomic Energy. Then came a plethora of milestones from Aryabhatta, SLV-3, which was the first launch vehicle which we have designed and developed, which could carry around 40 kg payload or material to space. INSAT, our first launch, Rakesh Sharma went to space in an intercosmos collaboration mission. Then came PSLV, GSLV. We had a space capsule recovery experiment, which was a precursor to a re-entry mission, which was conceived long back in 2000s, early 2000s, as a precursor for GAGANYAAN mission, which is going to come up. Chandrayaan 1 was launched in PSLV during 2008. Mangalyaan 1, we have reached the orbit of Moon. GSLV Mark III, as we have seen in the previous slide, was tested and proven. We are moving ahead with a reusable launch vehicle where we have a space plane, the air breathing propulsion scramjet is being tested. We went to Moon again in Chandrayaan 2. We tried to land, but unfortunately we couldn't soft land. But still, we went to Moon. We are gearing up for another Chandrayaan mission, Chandrayaan 3, where we'll be accomplishing the landing. And of course, Gaganyaan, the next milestone. And these are the people who are the architects of Indian space program. As I've mentioned, it all started under the able leadership of Vikram Sarabhai. He is known as the father of Indian space research. Dr. APJ Abdul Kalam, who is a former president of India, who is fondly known as the missile man of India. He inspired a lot. He was the project director for the initial launch vehicles of ISRO. Professor U.R. Rao, who was a satellite expert, commemorating his name, we have given the Space Center of Bangalore as U.R. Rao Space Center now. Professor Satish Dhawan, who was a successor of Vikram Sarabhai, and he was a wonderful personality who established various technological advancements in Indian space sector. And his leadership, we have developed the rocket launching station in Sriharikota, so it is named after him. And a brief about the organization of ISRO, Indian Space Research Organization, directly come under the Prime Minister of India as Department of Space, and we have a commercial wing called NSIL, which New Space India Limited, which will take up the commercial activities of Indian Space Research Organization. We have got various centers, PRL, we have got SCL Chandigarh, we have got Indian Institute of Space Science and Technology, which is the only space technology teaching institute in entire Asia. We have got various centers, VSSC Vikram Sarabhai Space Center, LPSC talks about liquid propulsions and the research and development. The SDSC SHAR is the Satish Dhawan Space Center, which is the rocket launching station of ISRO. URSC is Satellite Center. SAC is Satellite Application Center, which is in Ahmedabad. We've got Human Space Flight Center in Bangalore. Other centers are IPRC, ISRO Propulsion Research Center, which is in Tamil Nadu, and other centers take care of the electronics as well as the tracking of a launch vehicle as well as satellite. IIRS uses the data from the satellite for the development of the country. Moving on, this is our fleet of launch vehicle. We started with SLV-3, which could take around 40 kg to space. We augmented it to augmented satellite launch vehicle, which could take around 150 kg to orbit. And later we came up with PSLV Polar Satellite Launch Vehicle, which is the workforce of ISRO and can carry approximately 2,000, nearly 2,000 kg to orbit. GSLV came up with the indigenous cryogenic stage, GSLV Mark II, and it can carry 2,200 kilogram to geosynchronous transfer orbit, where our communication satellite resides. That is actually around 36,000 kilometers from the surface of Earth is what we call the geosynchronous orbit, where the satellite matches with the rotation of Earth. And GSLV Mark III is the heaviest launch vehicle, which can carry around 4 ton to geosynchronous orbit and approximately 10 ton to the low Earth orbit. And this is a vehicle which is developed for human application as human rated launch vehicle for GAGANYAAN mission and the future exploration missions. Yeah, we are on news. We've got, and this is the image of our beloved chairman, Dr. K. Shivan. He, under his leadership, we are looking at various missions. We are looking at uh, Venus for an exploration of Venus in 2023. We are planning a space station in 2030. This has been in news. We are looking at Moon and Mars again. GAGANYAAN, of course, is the highlight. India's first human exploration program, and the aim of the project is to launch 3-member crew on board GSLV Mark III, which is going to be human rated launch vehicle to low Earth orbit. For around 3 days, people will be there. They do a lot of experiments, and bringing them back safely is also a challenge. And you can see the orange color spacesuit, which was jointly developed by DRDO as well as ISRO for the GAGANYAAN mission, and the launch vehicle modified GSLV, which is named as human rated launch vehicle, because a lot of things need to be rated for human exploration as human rated systems, and this launch vehicle is human rated. It will be called human rated launch vehicle. And this is a gist of the mission. We will be planning for 3 missions, 2 unmanned missions prior to the manned mission, to test all the technologies, to prove that it is safe for humans to go there and come back in our systems. We are having a first mission in 2021. Later, subsequently, we'll going ahead with the other 2 missions. GAGANYAAN crew module and service module are the systems which takes the crew safely there and bring them back safely. This is the first image. The brown color capsule is the crew module, in which the crew will be housed. The 3 people will be there. It's roughly 3 meters in diameter, and the service module will provide all the environmental conditions and the waste management, all the oxygen supply for the crew in orbit. So once the orbital mission is over, service module will be ejected out, and the crew module will bring them back safely. We have to face a lot of challenges to come up with a safe human mission. So the first challenge is space transportation systems. That is, of course, the launch vehicle, which we are far advanced. Life support systems. Since we are venturing into such a mission for the first time, we need to know about the life support systems which are essential for a human spaceflight mission. Human rated platforms, as I mentioned, all the systems need to be safe for humans. So human rating is a criteria. Crew training facilities. We need to establish the crew training facilities. As of now, the selected astronauts, or the speculated name Vyomanauts, will be training. They are training in space systems in Russia currently, in Yuri Gagarin Cosmonaut Training Institute. Then the escape systems need to be developed. We have tested our pad about test systems, which was in news, of course. Then international support. Since we are venturing for the first time, we require support in many of the systems, which we will be looking at the standards established by pioneers in the field. And this slide talks about the mission profile of GAGANYAAN. We have a liftoff. We reach the orbit around 400 kilometers from the surface. We deploy our power harnessing on orbit, do the experiments for the 3 days which we are on orbit. Once the mission gets over, we'll deboost. That means we'll slow down our spacecraft so that it can enter the Earth's atmosphere once again. So while coming back, we don't need the service module for the further part of the mission. So we take the crew in the crew module. CM stands for crew module, SM is for service module, and crew module will re-enter. It will do aerobraking. Aerobraking is a process of reducing the velocity of the capsule by making use of the friction of air. And this generates enormous amount of heat, which will be survived by thermal protection of the crew module, which will be later slowed down by deploying parachutes and will splash down in the Arabian Sea. You can see the overall profile of the mission. This is India. It starts with Sriharikota and we goes to orbit. It goes around the Earth for around 3 days. Once the mission gets over, we'll deboost and come down and land in the Arabian Sea. And these are the which are planned in GAGANYAAN mission as a research platform. There are around 8 number of life science experiments. There are 7 number of space medicine experiments and 5 number of fluid and material experiments to be planned, and other scientific areas like sensor development, any relevant areas which are requiring space atmosphere, space ambience. Then life support systems and bio waste management is an important thing for future missions that is also being experimented in space during our GAGANYAAN mission. These are the titles of the experiments which are planned for GAGANYAAN mission. This is by various organizations across India as well as from outside also. Talking more about crew module, you have a cut section of the crew module in which you can see the crew sitting. This is basically it is for 3 crew members, and it is shown here 2 people only. This is how they are going to be. This is the configuration of crew in the crew module while it is ascending as well as descending. This is a armchair in which they'll be sitting. The other systems, medical kit will be there apart from other oxygen and life support systems. The storage is in green boxes. Yellow box gives the free the fire kits in case of any accidents. The yellow is a color coding. Then the waste will be accumulated and taken in the blue boxes. And this is the hatch for the crew to come out and enter the crew module. And this is our launch vehicle, human rated launch vehicle. And this is a place where our crew is going to sit. The small trapezoidal area is where the crew module is going to sit. Crew module along with this service module is called the orbital module. And this is a cut view of the crew module and service module, which are having oxygen as well as nitrogen for pressurization and radiators for the temperature control of the crew housing. And we are coming back with the support of Indian Navy. We will splash down in the Arabian Sea, and Indian Navy will support us by bringing back us to land. And this is the image of crew module experiment which we have done long ago to test various systems, and we have successfully tested the crew module, the re-entry, parachute deployment, and many systems on board. And this is an image of Indian Navy officers supporting us to bring back the crew module. Thank you. That's all from my side on human spaceflight mission and GAGANYAAN in a gist. I would, before closing out, I'll recommend these books. Of course, C.V. Raman is there. Today is a day which we commemorate his great invention. So the other books are very inspiring, and I would recommend it to all the people, including the faculty as well as students, to read through these books, which gives a lot of inspiration as well as insight towards space and science. You can see October Sky is there, which is a book which has come up as a book as well as a movie. Thank you. I can take a few questions if you have.
Yeah, thank you very much, Dr. Arun GI, for your beautiful session over here. And it looks like, that you actually took us into space and also made us, and also gave us a soft landing. Now, there are plenty of questions out over here, but we'll be taking only those questions which are more relevant to the talk that actually that has been given by. Okay. So I'm coming to the first question. This is by Tejas Shekhar Patil. He's saying, now this is a very good question. He says that, sir, unlike GPS, ISRO also has NAVIC, but why most of the devices don't support NAVIC in current scenario?
Yeah, that's a wonderful question. Actually, we are looking at we were looking at the indigenization of many of the systems. We have had IRNSS, Indian Regional Navigation System, satellites which are currently in space, in orbit, which are having very good images of Earth, India, and the associated areas. And it provides, it is going to provide us the same or even more clarity images than what we get from GPS. GPS is actually US Marine based system, which they take the first quality and they give us the service, and we use as that service. So currently we are having Navik, which is based on Indian regional navigation satellite system. Actually, it is getting implemented only. It takes a lot of time to test and come up with the actual data, because we need to test the accuracy of the systems. We need to test the resolutions. We need to test the continuity of the images and signals. So all these things takes a little bit of time. It is currently on the go. Very soon we'll have all the systems equipped with Navik. Now, on experimental basis, many platforms are using Navik system, but it will be soon as on a basis. It will be soon coming up for public usages. I think I've answered your doubt.
Yeah. Okay. So thank you very much, sir. So there is another question. Once again, this also is very much relevant. This is by Manish Singh. Is it possible to create zero gravity on Earth? And if yes, how?
Yeah, zero gravity. Actually, we need people to be trained before they are sent to space. So we create zero gravity, nearly zero gravity in Earth. There are very few methods available, but we make use of it very efficiently. One is, okay, first, what is zero gravity? You experience when the weightlessness when you come down in a lift. That is actually zero gravity, or somewhat weightlessness. That is the same thing in a enhanced stage which we experience in space. So what we do is, like, we do parabolic flight. Okay, you go up, you will feel heaviness of your mass will be heavy, your weight will be more. When you come back, you will be free falling. Actually, gravity is free falling. We are moving around orbit, means we are falling from one point to the other point. So free falling is generated or created by parabolic flight paths, which will help to train our crew to experience zero gravity situations. This is actually this image of are you seeing the slide? Can you see the slide?
Yeah, yes, sir. Yes, sir. We can see this.
Yeah, it is actually Stephen Hawking is coming in a parabolic path. There are flights which fly in parabolic path to create zero gravity conditions. Actually, NASA is having a flight called Pegasus, which is a Boeing flight which will fly in parabolic path, so that zero gravity effect can be generated for around 10 to 15 seconds. That is how we can create it. Another way is by using centrifuge kind of systems, which will give a feel of zero gravity. But this is the general method used. Otherwise, you'll have to jump from a building to experience zero gravity. For training people, we use the space agencies uses parabolic flight paths for creating space environment or zero gravity conditions.
Oh, thank you. Thank you very much, sir. There is this question is from Siddharth Nair. Now, in the journey to the outer space, is radiation always a thing to worry about? And how does the spacecraft and the crew deals with it?
Can you repeat the question? It was not clear.
Yeah, in the journey to the outer space, am I audible?
Yeah, please.
Yeah, in the journey to the outer space, is radiation always a thing to worry about? And how the
what to worry about?
Is radiation.
Radiation, yes.
Is a thing to worry about.
Yes, radiation. Yeah, radiation is a very dangerous thing in space.
And how the spacecraft deals with it.
Yes, that's a very good question.
And
actually,
we have people.
Yeah, we have people staying in space for around 365 days in our International Space Station, and are dealing with the radiation, cosmic radiation, which are very dangerous. X-rays of high concentration is coming and hitting the habitats which are equipped for the crew in doing the experiment in the National Space Station. People who are traveling from Earth to space also experiences huge radiations. Actually, these radiations are very dangerous for human cells or living cells. They can do affect in the form of mutations and cause cancerous issues. Actually, what we deal with is we have materials. Our very strong material development engineers and scientists have come up with solutions which can absorb radiations that come from outer space. Very good example is polyurethane is a very like renowned material, which is actually polyurethane is different type of polyurethane is available. Polyurethane is a polymeric material which we generally see in our foam bed and all. Polyurethane made from this aliphatic. You might have learned about aromatic and aliphatic compounds in our well-standard chemistry. Aliphatic based polyurethane are good in good against UV radiations, ultraviolet radiation. Similarly, lead-based material is protecting against X-rays and other radiation. So these kind of materials which are developed will be covering our crew module and space habitats, which will protect the material, protect the people and material inside from the harmful radiations that are coming in. There are many experiments going on the crew who are there in space about the radiation effects. So it is being studied. Actually, in zero gravity conditions, many problems we'll have to encounter, the crew need to encounter. One is the loss of gravity causes disalignment of the muscles and causes muscle loss. So they need to exercise huge, like large time they have to exercise. Around 4 hours they'll have to do exercise to keep their body fit. That is one problem. Then again, the radiation. Radiation, actually, they will have a housing which will protect them from the external radiations. So they'll be safe while going there and coming back. But still, it is ongoing research how the effect of radiation can be reduced. So it's going on, but still our people are safe because we have had materials since the beginning. We've had materials which will protect them from the harmful radiations. Is that okay?
Yeah, I feel that will actually serve our curiosity. Then we have one more question from Nishita Jagdale. She's saying, once the rocket is sent into space, what happens to the other parts that falls off after the 3-stage separation? Do they remain still in the atmosphere? Or means what she means,
that is also
remain still in space. That's what she means.
Yeah, that is actually a very good question. What we have seen is expendable rockets. These rockets which you are seeing in the screen are called expendable rockets, except this one, the reusable. So other rockets are expendable. That means each stage will be spent once it is burned off. That is called stage separation. So all stages will be separated out and the required payload, which are the satellites, will be put in orbit. What happens is each stage during the atmospheric ascent, the burnt out stages will be falling away or falling to the ocean. So if you see the launching stations of all the space stations, the Baikonur station of Russia, Kazakhstan, NASA, Florida Space Center, Kennedy Space Center, and Indian Space Research Organization, Sriharikota, all of these launch stations are near ocean. It is by the side of ocean. So when you launch a rocket, we'll make sure that all the spent stages of rocket during the atmospheric phase will be falling onto ocean without affecting any human habitat or inhabitation. So that will not be affected. It will not fall over human habitat areas. It will fall in the ocean. Okay. Regarding the upper stages, like beyond in PSLV, the PS4 stage and the upper stages, the heat shield, all these things will remain in orbit for some time, because once we go up the atmosphere, beyond the atmosphere, around 100 kilometers is generally considered as the Kármán line, which is the boundary of space, which is accepted so far. And beyond 100 kilometers, it is told that the gravity is very less, so it will take some more time for the parts and the stages to come back to Earth. So it will remain there and it will orbit. Once the speed is, due to the heaviness, the speed will be reduced. Once the speed is reduced, it will fall and burn away in the atmosphere. Generally, it will not affect, but if it is in a higher orbit, it can remain as space debris. That is what we have seen in the second slide regarding space debris. What we encounter in space includes space debris also. The man-made debris is the spent stages of rocket, upper stages of rocket, as well as the satellites which have completed their mission. So those satellites which are non-functional, and the satellites which has completed their mission period will remain in orbit as debris. Those debris will subsequently burn away. Satellites, what we do is like we'll push it with the balanced fuel to a higher orbit called decommission orbit or graveyard orbit, where that satellite will remain in the orbit because of lack of gravity. It will remain for a large time. If at all it comes down, it burns in the atmosphere due to the friction which the air creates. Is that fine?
Yeah, I feel that should be okay, sir. Thank you very much. Now we have one direct question from Nair Akil. He's saying, after computer engineering, how can I get a job at ISRO?
You need not mention computer engineering. Engineering is sufficient. Like engineering is basically the logic of the bringing out the logic inside a person. So what I believe is like opportunities are there for any science and engineering enthusiast. You finish your graduation, look for opportunities in ISRO website. We have got ample opportunities coming up. So many people are required to come up with to continue with our space exploration. Computer engineers generally do all the computer related, like electronics and computer related. Actually, we have got mechanical systems, we have got electronic systems. So there is a linkage between these two, and that is run by the computer people. So there are ample opportunities for computer engineer in ISRO. We are calling for people who are graduating from various colleges in computer engineering also. So it is available. You can just check the ISRO website, which is having a recruitment tab. You can just check there. Call will be there definitely for all engineering branches: civil, mechanical, electrical, electronics, computer science, and even architecture. People are being called in NASA. They have a space architecture wing where the design of space stations and the habitation things are being designed by architects also. So there are ample opportunities for all engineering branches and science people also. We require scientists also to take care of all the science exploration missions. So there are opportunities. Don't worry. You can just check the recruitment site.
Okay. A couple of questions, a few more are there. Okay.
Yeah.
Okay, Dr. Arun, please, it's a sincere request because these are budding minds, and we don't.
Definitely, I would like to spend some more time.
And
okay.
So please don't mind that. And this questions, they're truly thought over it. That's how they're putting it in the chat box. So there is another question which is given by Harsh Mahendra. He's saying, sir, then does the spacesuit radiation resistance material for astronauts? Okay, means that is also during spacewalk. Does that also has a anti-radiation material? That's what he's actually trying to ask.
Yes. Because as you have seen in one slide, there are different type of spacesuits. See, this is actually some. You're seeing the movie poster of space cowboys, in which they are wearing some orange color suit. That is actually the space shuttle suit which NASA has developed, and white color suit which Neil Armstrong was wearing in his moon landing is called the EVA suit, extravehicular activity suit. So the suit which they wear when they go out is different. The suit which they wear inside a pressurized capsule is different. So you require a pressure to maintain your body conditions, health conditions. You require something supporting your health or your body conditions outside, plus protection from the external conditions. As I've mentioned, there are huge variation of temperature from negative 150 degrees Celsius to plus 250 degrees Celsius, even though we don't experience that extreme in our exploration areas, but still that variation exists. And the radiation, of course, the radiation, we are exposed to radiation when we are out of the space capsule. As I have mentioned, space capsule or space habitat will protect us when we are inside. Once we go out, we are exposed to it. So we require some dress or some material in the suit which need to prevent this radiation or protect the radiation from going in. Actually, whatever suits you are seeing in this image is having a layer of radiation protection material which will prevent or absorb the material that are coming in and will prevent it from going into our body parts. So it will have multiple layers. This is not a single layer thing, it's a multiple layer thing, and it's very heavy. which various agencies are trying to lighten up. So this spacesuit will protect the people who are going for an extravehicular activity, which is actually beyond the vehicle. You are going out and doing the repair, maintenance, and exploration. So you require a special suit that will definitely protect. And even the visor, which you are seeing for the helmet, is having radiation protection. Similar to our sunglasses, which will help us to protect from UV radiation, this is having a further better protection for the astronauts since they are exposed to the radiation. So the spacesuit definitely safeguard the astronaut once they go out.
Okay, thank you very much, sir. The next question is from Sahil Patil. He is very much bent to know, that, sir, please explain what actually is aerospace or astronautical engineering and how to get into it. Okay, he's once again writing, please, sir, tell me. So can you just
yeah, that is actually a very enthusiastic mind. Definitely. Space is defined as something which is beyond the atmosphere of Earth, and that is outer space. Airspace is something which is within the atmosphere of Earth. So airspace deals with the flight, aeroplane, and outer space deals with the space flights or space modules and rocket engineering. When a rocket moves from Earth's surface to outer space, it travels in both the regimes. Airspace, it travels in the airspace, goes beyond the airspace and reaches the outer space. So we call it aerospace as a whole. Like we deal with area as well as deal with the outer space area. So it is called generally as aerospace engineering, or engineering that deals with aerospace is termed as aerospace engineering. It teaches about all the engineering aspects what we study in mechanical engineering, plus whatever that we encounter in an moving in an airfield as well as an outer space field. So that is actually aerospace engineering. Aeronautical engineering means you are specifically going into the mechanical portion of a aircraft or a spacecraft. That is what aeronautical engineering talks about. If you see when we were talking about inspiration, you can see the people who graduated from MIT and joined NASA are having aerospace engineering, and this lady Kalpana Chawla is having an aeronautical engineering degree. So aeronautical and aerospace deals with two different aspects. Aerospace engineering deals with the space field as well as the airfield conditions that we are going to survive when we move in a launch vehicle or a rocket. And aeronautical engineering deals with the mechanical aspect of the same. And getting into these, actually aerospace engineering is available in many of the engineering colleges across India. Aeronautical engineering is also available in many of the engineering colleges. IITs are offering aerospace engineering. IIT Madras, IIT Bombay are having very good opportunities in aerospace engineering. If you are a graduate, you can look for a master's course in aerospace engineering. If you're a master's holder, you can go for a PhD in aerospace engineering. No matter which branch of engineering you study, only the passion matters. If you are interested in any field, go and pursue it. Nobody is going to stop you from getting what you really want. So work for it, read through, get acquainted with the terms, and go and attend the interviews boldly and get through, because it's not that tough to learn anything. Only you require the mind to sit and learn as required.
Okay, yeah. Sincere thanks for that very encouraging reply, sir. Tejas Shekhar, he's telling us, he's asking us, tell us in brief about the SSLV launch vehicle.
Yeah. SSLV is small satellite launch vehicle, which is almost ready for launch. In this year, soon we'll have a SSLV launch. It is basically a 3-stage launch vehicle. We have a SS1, which is around. You can get all the data from Google also. The same thing only I can also tell right now, but still I'll just brief it. we have it is a full solid rocket. We have generally for rocketry, we have solid propellants, we have liquid propellants, we have cryogenics, we have semi-cryo engine. So PSLV is a solid as well as liquid stage launch vehicle. GSLV and GSLV Mark III is having solid stage, liquid stage, and cryogenic stage. But SSLV is a purely solid stage where we have SS1, which is the first stage, which is around 21 meters, and 80 tons is the loading, propellant loading. Beyond that, we have SS2, which is again solid. SS3 is there, which is again solid. Both are having almost similar configurations. Then the payload and the velocity trimming module. So SSLV is a full solid rocket which can take up, which can take very lighter payloads. Like people like you are coming up with nano satellites, pico satellites, and all, which require very small launch vehicle to take them up to very low orbit for exploration. So this launch vehicle is below PSLV and is very capable of taking very low payloads, very low weight payloads to low orbits, low Earth orbits, and it can be a very fast assembly launch vehicle also, since it is a solid propellant launch vehicle, which we have conceived as a vertical assembly system as well as a horizontal assembly system. So you can assemble it very fast and can launch in a very short period of time. So it's a very, very new system which is going to come in the possibly in this year itself. We'll have a first launch, SSLV launch, small satellite launch vehicle, small satellites, nano satellites, pico satellites, which are by various organizations across the world. We already have had the first launch contract with many organizations. We are launching a few satellites in the first launch itself. Soon you'll get to see SSLV flying.
So, there is somewhere we have to say, that we have to stop. And there is one last question, which once again is a very direct question, that is by Ram. On what basis does one qualify for a space mission?
If you're asking as an astronaut, if you're asking for the qualification criteria for an astronaut, it is purely based on the space agency which you are taking up, because NASA has got a huge amount of screening techniques for selection of an astronaut. ISRO, as we know, we have people who've been selected for the GAGANYAAN mission. They are purely Air Force pilots, because those are the people who deal with all the tough situations during their training, and they are the people who are having the maximum endurance among us. So they fly the aircraft in all the configurations, and they deal with all the situations. So they are the most eligible people as of now for GAGANYAAN. And later we'll require scientists who go up there and do experiments. So these people will be selected based on tests will be there. There will be interviews. There will be physical tasks which will be given, and people will be trained once they are selected in all kind of situations, unusual situations which we are going to experience in space. And decision making is a huge thing in such kind of ambience, because like I mentioned, Air Force pilots are the people who take decisions in split seconds. So they are the right people as of now. And when we go to NASA or European Space Agency, very recently there is a news of European Space Agency hiring as people for astronaut selection has come up. Actually, they select based on the scientific background, the engineering background. You should have a basic degree. You should have a passion of working on such fields. Then you should be qualifying their exams. There will be interviews. There will be multiple levels of tests and interviews, which once you qualify, you can get into. No matter whichever branch you study, only the specialization and the passion matters. So once you clear it, you can get selected. And as I have mentioned, Raja Chari is US Air Force graduate from MIT. So he actually got selected among the 18 people who were selected for the Artemis mission and the future moon and beyond the moon missions. Like that, once you are selected, you'll be put to a lot of testing, lot of trainings. If you see the movie First Man, which talks about Neil Armstrong and his experiences on the first moon mission, in that movie they'll be showing a centrifuge in which he'll be sitting, a multi-axis rotation simulator, which you will be sitting in a chair, you'll be harnessed with all the belts, and finally you'll be taken in a ride. You'll be rotated in all the axes. So that actually gives a actual simulation of what is going to happen in space. You will lose your orientation, but still you need to be conscious. If you watch any of these space movies, they'll give a small glimpse of what the training is about. So I would recommend the movie Space Cowboys, which is about a few old men who go to space, and they once again go to all the training exercises, and finally they get qualified. So first thing is you need to finish your graduation, because that is the minimum requirement. If it is specialized to whatever required in a space environment, then that will be better. Go attend the tests and interviews. Once you clear it, you'll be selected, you'll be trained, you'll be put for the actual mission. So it can be in future, ISRO also may look up for engineers and graduates. Once they are selected, they'll be put in training similar to our Air Force pilots, and finally we'll send people. That's what anticipated.
Okay, so thank you very much, Dr. Arun, for your very enlightening talk. I feel one lecture is just not enough. And one question which I have from my side is, does Vikram Sarabhai Space Center, does it have any small kind of collaborative projects that they can do with the engineering students? Because
definitely.
this is I mean, as they are pursuing their degree. Because let me tell you a very simple instance that happened in our college itself, wherein we actually used a very simple experiment, basically using the interference of light to measure the thickness of a polymer film. And the students worked on it, measured the Young's modulus of that, they got it tested, and all of these were actually first year students, right? And they presented all this entire work at a conference in IIT Kharagpur. So does ISRO offer such kind of opportunities?
Definitely. If it is graduate students, if it is for graduate students, we have got collaboration with them. We have got opportunities for graduate students to come and work with us. If you contact our PRO, public relations officers, they take care of this thing. And every year, the students from various engineering colleges are working on projects, real projects with ISRO. We have got collaboration with colleges in the name of Respond program, where ISRO supports the colleges and supports with the facilities, and the eminent scientists across ISRO will be supporting them. So there are programs like Respond. You can note down, it is Respond program. You can talk with the PRO, and the relevant people can definitely support and help to come up with very good results. Like you said, whatever they have presented in IIT Kanpur and IIT Kharagpur, and that appreciation, that actually would mean a lot in when it comes to such a field of science, pure science exploration.
So because the point which you want to stress is that it is not necessary that you have to work in a very big organization. The science is always around you. The facilities is always around you. And let me tell you this fact that the college fully supported the students. It sponsored the students to actually visit IIT that way. So, so suppose even ISRO, for example, is having such kind of opportunities, we will definitely like to be connected with you in that regard. Okay. So once again, thank you very much for your talk. Sure. Please, sir. Please.
Yeah, actually, it was planned in 10:24 a.m. Maybe it might have gone by now. So it was PSLV C-51 had the main passenger as one Brazilian satellite, which is known, which is whose name is Amazonia. Amazonia is a satellite which has gone in PSLV C-51, along with a few other co-passengers, a few small satellites by various companies. I think Pixel has got one satellite in this thing. Whether it has gone or not, I'm not aware. But we've had many small satellites plus Amazonia as the main payload for the PSLV C-51. It was launched from, means it is supposed to be launched from Sriharikota. By now, it might have completed the launch vehicle part. It might have injected the satellite onto the required orbit. If you're asking regarding the specific orbit and the details, I think it is available in public media. I'm not currently remembering the actual orbit and details. You may get the data from net or yeah. Okay. 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 Yes.
Yeah,
Yes,
Yes.
sir. One last question, sir.
yeah,
Yeah.
please.
Sir, how do we get the images of our own galaxy? Means like, how do a satellite capture a pic of like our own galaxy, like Milky Way, without getting out for capturing the photos?
Definitely. That's a wonderful question. Actually, if you have heard about Hubble's telescope, that is one eye of eye which opens towards the outer space and the galaxies around us. So this kind of that is actually a spacecraft which is assembled and which is sent and assembled by the help with the help of space shuttle, and Russian modules have supported to maintain it. So actually, space telescopes are the like how do we see the image of a planet? We use telescope from here. How do we see moon? We use telescopes which are having very high resolutions to watch them and study about. So similarly, we have a telescope in orbit. There are some places in orbit where the gravity or effect of various planets, sun get cancelled off. That they are called Lagrangian points. So these Lagrangian points are specifically made use by various space agencies to put such orbital telescopes. These telescopes will be opening their eye towards the galaxies and outer space. So these will take the image of the galaxy and the stars at various time, and it will be combined together to get the full image. That's how we
Sir,
take it.
so
We
it
cannot go.
works
It
on the
may take a lot
reflection
of
only.
time in terms of light years to reach outside. Similarly, if you remember the name Voyager, which is a spacecraft, there are two Voyagers which have traveled outside the solar system, which is only a very small point, as we see in one image I have shown. Yeah, this pointer is pointing towards solar system, and the entire galaxy is being shown in as a huge, like it's like 1,25,000 light years across, and our Voyager has just passed the effect of solar system only, and still it may take millions of years to go at various time, at various configuration means events, and we combine all together, extrapolate and make such an image. It's not like we are going out and taking a picture. It's not possible at all in one lifetime. So what we do is like we'll take different pictures, combine it, extrapolate by scientific calculations. With the backup of scientific calculations, we arrive at such an image.
Okay, thank you, sir.
Yeah.
Okay, so when the world was launching people to the moon, India was firing simple rockets at Thumba. But today, we have moved ahead in leaps and bounds, and we are sharing the infrared satellite data with the entire world. Similarly, as we take these baby steps in manned mission, the day is not far when someone amongst you will be an astronaut and say, Sare jahan se acha, from a completely Indian space station. Okay, so looking for Arun sir, once again, thank you very much from behalf of everyone at Pillai College of Engineering. Okay, thank you very much. And students have already written over there that they want the second lecture also very soon. So let us look forward to that also. Thank you, sir. Thank you very much.
Thank you. Thank you for the patience.
Thank you, sir.
And thank you for the questions. Thank you.
Yeah. Thank you. Thank you very much, sir. Thank you, sir. Thank you.